Do you feel the vibes?
Hello, grade 9, how are you all? This is Mr. Ahmed Samir and the first lesson in Unit 4. Unit 4 is called Trigonometry, and trigonometry is a mathematical branch that study the relations between the sides and angles of triangle. And the first lesson is the main trigonometrical ratios of the acute angle. Let's see our lesson today. First of all, we have a definition. The trigonometrical ratio of the acute angle is the ratio between two sides of the right angle triangle that contains what? Contains the angle relation or ratio between two sides that contains this angle. Example, if we have triangle ABC is a right angle triangle at B, like this. We have two examples here. Two triangles ABC at B, right angle triangle at B. So we have three sides for each triangle. The opposite side for the right angle is called hypotenuse, and the sides of right angle, one of them is called opposite for the angle and adjacent for the same angle. Opposite for the angle A, adjacent for the angle A. By the same way, angle C, the opposite for C is AB. The adjacent for angle C is BC, and the hypotenuse is the opposite for the right angle B. Again, we have three sides. For the angle A, the opposite BC, the adjacent AB, the hypotenuse AC. For the angle C, the opposite AB, the opposite for angle C, the adjacent is BC, and the hypotenuse AC. We will study three ratios in this lesson. Number one is called the sine of the angle, is denoted by sine equals the opposite over the hypotenuse, the length of the opposite side over the hypotenuse. Number two, the cosine of the angle is denoted by cosine, C-O-S, cosine. It is called the length of the adjacent over hypotenuse. Cosine equals adjacent side over hypotenuse. The last ratio in this lesson, the tangent. The tangent of the angle is denoted by tan. Tan is tangent equals the opposite over the adjacent. Again, sine is opposite over hypotenuse. If we have an example like C, if I want sine C equals the length of opposite over hypotenuse. Cosine C, cosine angle C, equals the length of adjacent over hypotenuse. Tan or tangent of C equals opposite over adjacent. Let's practice by an example. If there is triangle XYZ, XY 7 cm, YZ 24, and XZ 25. XYZ is a triangle, right angle triangle at Y. Angle Y is a right angle. Now let's study the ratios of sine, cosine, and tan for this triangle. First of all, sine Z by the rule equals the opposite over hypotenuse. Opposite of Z is XY, 7 over hypotenuse equals 7 over 25. Cosine Z is adjacent over hypotenuse. The adjacent for z is yz equals 24. Adjacent over hypotenuse equals 24 over 25. Tan of z equals the opposite over adjacent. The opposite of z is xy. 7 over adjacent equals 24. Then will be 7 over 24. For angle x, sine x is opposite over hypotenuse. Opposite of x is yz, 24 over hypotenuse 25. Cosine x equals adjacent over hypotenuse. Adjacent 7 over 25. Tan x equals opposite over adjacent. Opposite for x 24, adjacent of x 7, then tan x equals 24 over 7. Another example, triangle, the right angle triangle ABC has right angle B and length of AB 3 centimeter and BC 4 centimeter. First of all, we want to get the length of the side AC. From Pythagoras theorem, we can get the side AC. Let's see. AC square equals, or the hypotenuse equals, AB square plus BC square. AC square equals AB square plus BC squared. Then it will be EB square 3 square plus BC square is 4 square. By using your calculator, it will be 25. But I want AC only without square, so we will take the square root 4. 25 will be 5. Now we have the length of all the sides of the triangle. Now sine A opposite over hypotenuse 4 over 5. Cosine A adjacent over hypotenuse is 3 over 5. Tan A opposite over adjacent 4 over 3. Sine C opposite over hypotenuse is 3 over 5. Cosine C adjacent over hypotenuse 4 over 5. And tan C is opposite over adjacent 3 over 4. Let's see another example. Triangle ABC is right angled at A, in which AB equals 9 cm, AC 12 cm. Find the value of 2 cosine B tan B minus sine C. In this example, first of all, you must draw this triangle. We will draw right angle triangle like this. Is a right angle at A, so the right angle is A. AB is 9 centimeter, AC is 12 centimeter, and the opposite for the right angle triangle is the hypotenuse BC. The hypotenuse here is BC. Now the question, find the value of 2 cosine B tan B minus sine C. Let's get the ratios of cosine B, tan B, and sine B. But first of all, you must get the length of BC, the length of hypotenuse. By using Pythagoras theorem, AC equals 12, AB equals 9, but BC, the hypotenuse, BC squared equals AB squared plus AC squared will be 9 power 2 plus 12 power 2 by your calculator 225. I want BC without square. We will take the square root of 225 will be 15. So BC equals 15. Now we can get the ratios, the required ratios. Number 1, cosine B, adjacent over hypotenuse, 9 over 15. Secondly, tan B opposite over adjacent, opposite over adjacent, 12 over 9. The last ratio is sin C. Sin C here, opposite over hypotenuse, 9 over 15. Now let's substitute in the question. 2 cosine B, tan B minus sin C. 2 cosine B means 2 times cosine B times tan B, like 2 times cosine B 9 over 15 times tan B 12 over 9 minus sin C is 9 over 15. You can put it on your calculator. The result will be 1. Let's see another example. In the opposite figure, AD perpendicular to BC and AB 13 centimeter, AC 15 and CD 9. Find the simplest form of the value tan of angle CAD plus tan of angle BAD over tan of angle CAD minus tan of angle BAD. First of all, we have two sides without any measurement, AD and BD, and we have two angles in the question, two required angles, angle CAD and angle BAD, the right angle. First of all, by using Pythagoras theorem, we can find the side AD and the side BD. In the triangle ADC, we can get the length of side AD. AD is side of right angle. So by using Pythagoras, AD square equals AC square minus CD squared equals 15 power 2 minus 9 power 2 equals 144. We will take the square root, will be 12. So AD is 12. As triangle ADB, we will find the length of the side BD. BD is a side of a right angle. By using Pythagoras theorem, BD squared equals the hypotenuse AB minus AD will be 13 power 2 minus 12 power 2 equals 25. The square root of 25 will be 5. So BD equal 5. Now let's find the required question. Tan of angle CAD. I want tan of it is opposite over adjacent, 9 over 12. 9 over 12 plus tan of BAD is red angle, tan of it opposite over adjacent, 5 over 12 over tan of CAD, we find it before, will be 9 over 12 minus tan of BAD is 5 over 12. 9 plus 5 is 14 over 12 over 9 minus 5 is 4 over 12. We will cancel 12 with 12 to put it in the simplest form. Will be 14 over 4 equals 7 over 2. We finished our lesson today. I hope you benefit from this session and wait for me next session. Goodbye.